Good evening. I welcome you all for today's section, Programming ROM Allocation in C. So here we are going to discuss how the ROM is programmed and how we are allocating ROM in C. So here first we should know the introduction of ROM. We know very well ROM is read-only memory. It is a type of memory that retains its contents even when power is turned off. It is commonly used for storing firmware, software that is closely tied to hardware and doesn't need any frequent updates. So the purpose of programming RAM allocation is in embedded system and firmware development, managing ROM efficiently is crucial for optimizing space and performance. So allocating RAM effectively involves organizing the code and data to minimize space usage while ensuring accessibility and maintainability. So this is all about what is RAM and what is the purpose of programming RAM allocation. So the strategies for RAM allocation. Here are some types for RAM allocation like code optimization, data compression and selective inclusion, etc. Code optimization. It is a compiler optimizations to reduce code size without sacrificing the functionality. So in queues like loop unrolling, inlining and constant folding can significantly decrease the size of compiled code. So the next one is data compression, where we have to compress data stored in RAM to save space. We have to use algorithms like Huffman coding or LZ77 to compress data before storing it in RAM. So the decompression routines are then included in the firmware to unpack data as needed. And next one is selective inclusion. So to include only the necessary parts of libraries or modules to minimize ROM usage. So the conditional compilation directives can be used to include or exclude sections of code depending the configuration. And the next one is read-only data, then memory banking and overlay techniques. So the read-only data here is constants, lookup tables, etc. with the constant keyword, the compiler to store them in ROM. It ensures that data is stored in non-modifiable memory, reducing RAM usage. And next one is memory banking. So it divides ROM into banks and load only the necessary banks into memory as required. So the useful for systems with limited RAM space where not all code data need to be loaded simultaneously. The next one is overlay techniques. It uses overlay techniques to manage code that exceeds available ROM space. So the different parts of the code are loaded into memory as needed, swapping out sections when they are no longer required. And next one is implementation in C. So the compiler specific directives or linker scripts to specify ROM allocation requirements. We have to utilize constant keyword to declare read-only data. Employ conditional compilation directives to selectively include exclude code based on requirements. To implement compression and decompression, routines are necessary optimize critical sections of code to minimize size while maintaining performance. So the ROM allocation is essential for embedded system and software development. By employing various strategies such as code optimization, data compression, and selective inclusion, developers can effectively manage ROM usage. Careful consideration of memory usage and optimization technique can lead to more compact and efficient firmware designs. So this is all about our programming allocation in RAM. Thank you.